All right, let's dive right into this explainer. You know that feeling when you look at a screen full of computer code and it literally looks like an alien language? Yeah, you're absolutely not alone. But today, we are going to completely demystify programming. We're tackling Python, which is one of the most popular programming languages in the entire world. And we're going to do it by treating it not as some complex math problem, but as a simple manual for a very literal robot. By the end of our time together, you'll understand exactly how to give this robot instructions to do some seriously incredible things. Here is the roadmap for our robot manual today. First, we'll meet your literal robot. Second, data, boxes and toys. Third, logic, decisions and chores. Fourth, reusable magic spells. And finally, fifth, we'll map out the Python roadmap.
All right, Chapter 1, Meet Your Literal Robot, Understanding Python.
So here's the absolute key to Python. It's insanely popular precisely because it reads almost like English. You really don't need a math degree for this. Instead, I want you to picture Python as a very helpful, super eager to please, but, well, extremely literal robot. That's the core metaphor here. If you give this robot clear, step-by-step instructions, it can do mind-blowing things. It can process data, build websites, run complex games, the whole shebang. But if you're even a little bit vague, or if you skip a single step, it gets completely confused. It doesn't know what you meant to say. It literally only knows exactly what you did say.
Moving on to Section 2, Data, Boxes and Toys, Variables and Data Types. Okay, so Python handles data a lot like everyday physical objects. Imagine you're standing in a room just full of boxes. To keep things organized, you'd slap labels on them, right? Well, in Python, these labeled boxes are called variables. Say you have a box labeled my_age and you drop the number 10 inside it. Boom, that's a variable. Now, what goes inside these boxes? We've got integers. These are your whole numbers, 5, 10, 100. Think of them like solid wooden counting blocks. Next up, we have strings. These are just words or sentences, and in Python, you've always got to put them inside quotation marks. Picture a literal string of alphabet beads tied together. So the name Alex, in quotes, that's a string. Finally, booleans. These are so simple. They are literally just true or false switches, exactly like flipping a light switch on your wall. So looking at some real code, name equals Alex is our string of beads, age equals 12 is our integer blocks, and is happy equals true is that Boolean light switch flipped right to the on position.
Next up, Section 3, Logic, Decisions and Chores, Conditionals and Loops. So how does a robot actually make choices? We call this the if game, though formally they're known as conditionals. Honestly, it's just like a choose-your-own-adventure book. You're setting up a scenario for the robot. The code reads literally like a normal sentence. If the weather is exactly equal to rainy, then print, take an umbrella. But hey, what if it's not raining? Well, that is where the else command comes in. The code just says, else, print, wear sunglasses. It's pure cause and effect, guys. If this thing is true, do action A. Otherwise, go ahead and do action B. Okay, decisions are covered. But what if you need the robot to do the exact same thing, say, 100 times? You definitely do not want to write that instruction out 100 times by hand. That's where our again and again machine jumps in, otherwise known in programming as loops. And there are two main flavors to know here. First, for loops. You use a for loop when you know exactly how many times you want the robot to do a task. The command is basically jump 10 times. You see the finish line before you even start. On the flip side, we have while loops. You use these when you want the robot to keep going until something specific changes. The instruction is more like, keep jumping until you get tired. It could be 5 jumps, maybe it's 50. The loop just keeps on spinning as long as that condition stays true. All right, Section 4, Reusable Magic Spells, Functions, Lists, and Dictionaries. Let's kick this off with functions. Guys, a function is literally like a magic spell. Imagine having to explain to this very literal robot exactly how to make a peanut butter sandwich every single time you got hungry. Open the bread bag, take out 2 slices, unscrew the jar, find a knife. I mean, it would be absolutely exhausting. So instead, you write those instructions down just one time and give it a name, like make sandwich. You have just created a magic spell. From then on, whenever you want a sandwich, you don't repeat all those steps. You just tell the robot to cast that make sandwich spell. You can even hand it different ingredients later, like cheese instead of peanut butter. Name it once, cast it whenever you need it. It's a real game changer. Now, when you've got way more than just one variable, you're going to need lists and dictionaries. Think of a list as a shopping list, or maybe an orderly line of people waiting. Every item has its own specific spot. But, quick side note, here's a really fun quirk about Python and a lot of other programming languages.
The line always starts at position 0, not 1. So if we have a list of toys like Lego, ball, and robot, that Lego is sitting right there at position 0. Okay, next we have dictionaries. Picture a real dictionary, or maybe a treasure map. Instead of numbered spots in a line, dictionaries use a key and a value. The key is like the word you're looking up, and the value is the definition. In our example here, we've got a dictionary called Hero. The key name has the value SuperPython, and the key power holds the value coding. It is just a fantastic, clean way to bundle related information all together in one place. Moving into the home stretch, Section 5, the Python Roadmap, your course from beginner to intermediate. All right, here is your literal 4-week blueprint. Week 1, that's the foundation. This is where you'll install Python, open up an editor like VS Code, learn your basic math, plus, minus, multiply, divide, and figure out how to actually talk to your program using input and print. Then, rolling right into week 2, you hit logic and control. You're going to master comparison operators, checking if 5 is greater than 3 or if a name equals Manus. You'll also tackle nested if statements. That's basically saying, hey, if it's the weekend and it's sunny out, do this. Plus, you'll practice looping through those lists we just covered. Okay, week 3. This is where you build your toolkit. You'll start giving those magic spell functions specific ingredients, which are called parameters. You'll also start using modules. That's basically just borrowing other people's pre-written code, like importing a random module to make a quick dice game. And this is absolutely crucial. You'll learn error handling using try and accept. That teaches your robot exactly what to do if something breaks, so the whole program doesn't just crash and burn. Finally, week 4. This is where you become the architect. You're going to learn about classes and objects. Rather than just building one single robot, you create a robot class blueprint so you can just stamp out 100 different robots. You'll also pick up file input and output, which lets your robot read and write text files. That way it actually remembers things even after you turn it off. So, once you've got those core weeks under your belt, you arrive at phase 5. This is the final destination, where you stop doing basic drills and actually start building real projects. The source material outlines 3 amazing beginner projects for this stage. First, guess the number. The robot picks a number and you've got to use logic to guess what it is. Second, a simple to-do list program where you can add, remove, and view your tasks. And third, the adventure game, a fully text-based game where those conditional if choices you make actually alter the ending of the story. This is the exact moment where all those boxes, toys, and magic spells finally come together to create something you can truly interact with. And that brings us to the ultimate takeaway here. Programming, it is not a spectator sport. The manual leaves us with this incredible piece of advice. Don't just read the code, type it. The robot only learns when you actually give it the commands. I mean, you wouldn't expect to learn how to ride a bike just by reading a book about bicycles, right? And you definitely can't learn Python just by staring at a screen. You have to open your editor, make some mistakes, get the robot totally confused, and then figure out how to fix your own instructions. It's all about action. So my final question to you is this. Now that you hold the manual in your hands, what command are you going to give your literal robot first to kickstart your coding journey?